I have some example problems for you. You may want to pause this video at this point and try this on your own, and then press play to see how it's done, or pause it at any time so that you can work along with it rather than watching me do it. So first thing we're going to do is read the problem and write down all the givens. This problem says the frequency of thunder is about 100 hertz. So I'm going to write that down. The frequency is 100 hertz. And then it says, what is the period of a wave of thunder? So period is, well, I don't know. So this requires that we understand the definition of period. Period is the length of time required for something to occur, whereas frequency is how many times it occurs per second. Another way of writing the hertz is like this, s to the -1, which means reciprocal seconds. Or the idea is that this happens 100 times in 1 second. If you take the reciprocal of the frequency, you're going to get the period, which is how much time it takes. In fact, these two values here are reciprocals of one another. So what is the reciprocal of 100? We are going to now put that number on the bottom. It was 1 second, or 100 times for each 1 second. Now it's 1 second per each 100 times. And what is that? That is 1/100th of a second. Ask yourself, does this make sense? If it happens 100 times per second, then does it make sense that the time it takes would be 1/100th of a second? It makes sense to me. So we're going to move on to the next question now. And most of these questions are going to be using this equation that we went over with the lecture last week and in your textbook right here, that the speed of any wave is equal to its wavelength, which is abbreviated with the symbol lambda, Greek letter for L for length, and the frequency. So you're going to multiply the wavelength times the frequency in order to get the speed of any wave in a specific medium. So this would go for sound through air or light in a vacuum. So yeah. Also, you may see frequency written in other science texts as what looks like a curly V. And so next question, a wave has a frequency of 10 hertz and a wavelength of 30 meters. So we're going to write that down. The frequency is equal to 10 hertz. I am going to write this down in this form as reciprocal seconds because we are doing math. And to me, it makes more sense to have that per second than it does to have hertz. So I always switch to seconds whenever we're going to start doing math. The wavelength is 30 meters, and it's asking us for the speed. So notice how we've got all three things in this equation here. Two of them we know, and that means that the third can be figured out by algebraic manipulation. We're going to plug everything in. The speed, we don't know. So we just write it down. We'll figure it out. The wavelength is 30 meters. And the frequency is 10 reciprocal seconds, or 10 hertz. So it's telling me to multiply those things together, and I'm going to get the speed. The speed is 330 times 10 meters per second. And so does this make sense? That if something was moving 30 meters 10 times a second, that it would go 300 meters per second? It makes sense to me. Okay, example 3. The speed of sound is 346 meters per second. The frequency is 55 hertz, also known as 55 reciprocal seconds. And we want to know that wavelength. So I'm going to plug these values in because I have something for all of them. I have a 346 meters per second for my speed. I have I'm going to figure it out. So I'll leave that variable there for my wavelength. And then my frequency is 55 reciprocal seconds. You divide both sides of this equation by the 55 reciprocal seconds so I can get them to go away over here and have lambda all by itself. Over here, I will put into my calculator 346 divided by 55, which is 6.29. Units wise, I have per seconds here and per seconds here, so they cancel out. These are meters, which is what we would expect for a measurement of wavelength. Does this make sense? If it's going 346 meters per second, could it go a distance of 6 meters 55 times a second? Oh yeah, it's going pretty fast. Or if it went 6 meters, could it do it 55 times in 1 second? Well, at that high speed, probably. So it does make sense. Okay, second to the last one here, guys. So fisherman notices that one wave passes the bow of his anchored boat every 3 seconds. This is telling us the length of time it takes for this thing to occur. And so the frequency here is 1 cycle for every 3 seconds. This is also known as 0.33 repeating hertz, 1/3 per second. So notice that the period is 3 seconds and the frequency is 0.33 times each second. The wavelength is 8.5 meters, and they want to know how fast the waves are traveling. That is a request for speed. I feel the need for speed. Oh my goodness, I don't need those kinds of things going on here. All right, so we're going to take speed and make that equal to the wavelength, which is 8.5 meters times the frequency, which is that. Multiply them together and I will get 2.8 meters per second. I got the meters there and the per second there. And meters per second is an appropriate measure of a speed. It's a rate. I also would like to remind you at this time that there's that second way to calculate speed. It works for anything, not just waves. Take the distance that the object has traveled and divide it by the amount of time that it takes to travel that distance, and you get the speed of that object. And that's really what we're doing here, is taking that distance and dividing it by the time it takes to reach that distance. So does it make sense? If a wave travels 8.5 meters in 3 seconds, that it would be traveling this fast? Makes sense to me. Okay, last one. If the speed of a wave is 150 meters per second, and its wavelength is 75 meters, what is its frequency? So here we are, 150 meters per second. 75 meters is my wavelength, and this time I am trying to figure out what that frequency is. I'll be dividing both sides by 75 meters. And I can do this in my mind. The frequency is 2. The units are per seconds because your meters are going to cancel out here and we're still left with that S underneath there. So does that make sense? That if something was traveling 150 miles per hour, but it did it 75 meters at a time, 150 meters per second, but it did it 75 meters at a time, that it could do it twice in a second? Yeah, it makes sense. Thanks for your time. If you have any other questions or need any help, send me an email. Hope this helped.